General relativity, step by step. What I've been doing, I've been looking at the linear approximation to the Einstein field equations, and I have been multiplying out this expression here, which comes from factorizing the Einstein tensor on the left hand side of the Einstein field equations. And so I've got 1, 2 terms multiplied by 1, 2, 3, 4 terms. 2 fours are 8, and I've done the first lot here, 1, 2, 3, 4, and now I'm doing the second lot. I'm doing minus a half. This comes from the this component here of the Einstein field tensor multiplied by the 1, 2, 3, 4 terms of the linear approximation of the Riemann-Christoffel tensor. So here they are. We've got minus a half, plus a half, plus a half. It's a half because that's in the definition of the field tensor, and the sign changes after the second element because these first two are positive and then the third and fourth elements are negative, so the sign changes here. And all I've done here is write out the product of the etas, and I've written down the 1, 2, 3, 4 terms of the Riemann-Christoffel tensor. You can see I've made little notes here because this is about the 4th or 5th attempt that I've had to get all this right, and it's a bit of a pain, I have to say. So I'm going to pinch in and I'm just going to multiply these things out and hope we get some cancellation. I'm sure we will. Let's just have a look at this. What we've got here is a what do I want here? I want to raise all the terms I can. So I've got an alpha. Let's choose a slightly different color so it shows up. We've got an alpha, which is that term there. We've got a nu, which is this one here. So we're working with an h with two upstairs indices because I've raised them with the etas there. Let's write that down. That's h. And what are they? The nu has turned into a beta and the alpha has turned into a mu. That's nice. Have I got my half written down? Is it positive or negative? Can't remember. Minus. It's a negative. Minus a half. Oh dear. Let's go to orange. These guys here. Oh, that's red, isn't it? Never mind. Gamma, sigma, these are free. So I'm going to write that down on the right hand side in black. There's eta, gamma, sigma. And what's happened to my operators? We've got a beta and a mu on the bottom. And a beta and mu on the top there. So I'll just write that in. Di beta, di mu. There we are. That's quite nice. Equals. So we've done the first term. Yeah, and I'm just checking for consistency. In this term here, we've got a gamma and a sigma free indices upstairs. And here we've got gamma and sigma, but they are attached to the flat space metric eta. It's the same sign because we're considering the second term here. We're just going to go through the same process. Let me just change my colour to green, let's say, make it look nice. Yeah, it's a slightly different term. We've got lots of stuff going on here. We'll have to do it in stages. Let me raise this operator here. That alpha there sums with this alpha here. And so what we've got on the right-hand side is di mu upstairs, I think. Yeah. What have we got downstairs? Downstairs we've got a nu there and a beta there. So that turns into a di beta upstairs. Let me just mark that as done with red. That nu and that nu there leave me with a di beta upstairs. Di beta upstairs. So what have I done? I've done that one. I've done this one because they contract with this one and this one. We've got the gamma sigma, which is still free there, I think. Yeah. Eta, gamma, sigma. So I've done that one. And what's it acting on? It's acting on H, beta mu. Summed over beta, summed over mu. Okay, so those two terms are what they are. I'm going to stop there because this has already been 4 minutes, and I'll do the second two terms, the final two terms here. Stop.